Chapter 7.5 Loans. Now remember your project is coming up. So the project is based on Chapter 7, and the topic is going to be you're getting a loan either to purchase a car or purchase a house, or you try to get some kind of finance for your college future college tuitions. So these are the formulas you definitely want to be using. So here's another example. If you want to buy a house, $300,000 house with 10% down, and finance rest for 6%. Annual interest over 30 years. So this is a very much like what a project look like if you do choose to do the mortgage. So all right, so the first thing you need to figure out is how much the down payment is. So 10% of $300,000 is $30,000. So $30,000 is down payment. Now we take the $30,000 away from the purchase price. The rest of it we need to finance. So $270,000 is the loan we need to finance. So that's the loan amount. Okay, we'll put it in the formula. We want to know what's the monthly payment. That's D, right? That's a monthly payment. And 6% and monthly payment. So that means what, 12 times a year. That's why we get N equal to 12. So negative, don't forget this minus sign here, and 30 times 12. Okay, so once again, you use the calculator to do all this part, you end up with 166.79 D. When you divide that number on both sides, you'll come out with the monthly payment, which is $1,600 and $618.79. Now, what's the total interest she will pay for the entire loan, for the life of the loan? Now, you paid this much, $1,618.79 for every month. You do that so let's figure out how much you pay for 1 year. So multiply 12 and times 30. So that's how much you're actually paying to the bank, $582,764.40. Now, but remember, this is how much you pay in the bank, but you only borrow $270,000. So you end up paying bank in terms of interest-wise $312,764.40. You pay more interest than you borrowed. Yeah, that's how banking works. Okay, so you take how much you actually pay them minus how much you borrowed. That's how much the interest you have to pay the bank. The extra beside the amount borrowed. All right, so remaining loan balance. Okay, so we use this. It's to know, well, how much will the loan balance still, okay, if you start paying already. So for example, so the mortgage 6% annual interest payment is $1,000 per month, so N is 12 year. How much will the loan balance be 10 years from the end of the loan? All right, so if you pay 10 years into it, and how much you still have left over, right? So we put our monthly payment, $1,000 goes here. So use the formula 1 minus 1 plus 0.06 divided by 12 to the, again, don't forget the negative side, negative 10 years, T is 10 times 12, right? That's how many times we make a payment a year, which is 12. And then divide by 0.06 divided by 12. All that, if you punch all this in the calculator, you get $90,073.45. That's how much, after 10 years into the loan, that's how much remaining you still owe. Okay, here's another question right here, another example. This is the one with the car. Some of you might want to do the scenario involving purchasing your first car, so for your project. So for this example here, Emily bought a car for $24,000 3 years ago. The loan has 5-year term, so you already paid 3 years. She already paid 3 years. She had 2 years left, right? Okay, at the 3% annual interest. How much does she still own on the car? All right, I assume Emily should be a she, but $24,000 equal to, now here's D, right? Okay, so because, well, first of all, we don't know what's the monthly payment. Okay, so we everything else we know the interest rate, we know it's monthly payment, and we know it's 5 years. So once we figure this out, we find out the monthly payment for this car is $431.25. Now, We want to know the reason why we need this because we want to know how much the remaining balance is. But without knowing the monthly payment, we can't do that. That's why we do this first. Okay. Then we take that information, plug into the formula for balance, remaining balance. So that's our monthly payment. We figure it out, and everything else is the same. But notice this T is only 2 because we have 2 years left, right, out of the 5 years. So we already paid 3 years. We have 2 years left. So this T equal to 2. Once you do that, it tells you how much money you still owe. $10,033.45. All right, here's another example. A friend bought a house 15 years ago, taking a $120,000 mortgage at 6% annual interest rate for 30 years. How much does she still owe on her mortgage? And follow-up question, how much has your friend paid off this loan? Compare this to your friend's total payments. All right. So let's take a look. We know this is the mortgage original amount. Okay. Again, just like the previous question, we need to figure out the monthly payment. Unfortunately, they didn't provide us that. So we need to figure out what D is. We have the 6% for the interest rate. It's a monthly payment. That's why it's 12. And this is the 30-year loan. So we find out, okay, that after the calculation, when your friend first take out this loan, the payment is $719.47 per month. All right, now we're going to take that into our remaining loan balance formula. So that's the number we find everything out once we pay. So we bought, it's a 30-year loan, but we already paid 15 years because we bought a house 15 years ago. So we still have 15 left. That's why this T right here is 15. That's 15 remaining years, right? Okay. Then when you're done, I'll once again punch in the calculator. So we still owe this much money, $85,259.72. That's still all of the next 15 years. We still need to pay this off. Okay. Now, how much we already paid? This is a monthly mortgage times 12. That means 1 year times 15. That's 15 years. That's how much you already paid. Okay. Now, if you look, original loan was only $120,000. So even you just pay half the loan, you already pay more than what you owed. And that's just something interesting, okay, a eureka moment for you to think about. Okay, we borrowed $120,000, and this is for 30-year loan. So after 15 years, we already pay over than the principal. So basically, after anything after 15 years is a pure profit for the bank. Yeah, they already got their money back. Now, if you want to solve for time, okay, the same question. It's just what if time is missing? How long will it take for someone to pay off the purchase, right? Okay, so we use the same formula. We want to know how much the original price is. So we have a $1,000 laptop, okay, on a credit card, and it's 12 months, so it's 0.12. That's the interest rate compounded monthly, so that's where the 12 coming from. And we have the monthly payment of $30, right, a month. Okay, so when we do that, the only thing missing is T. All right, so you do your math here. Okay, the only thing you probably don't remember is, okay, after you multiply everything out, you find out the T is on top here. So you can't really multiply, divide, add, or subtract. The only way to do this is take a log on both sides. When you take the log on both sides, hopefully you still remember from beginning algebra days, then the third rule of log is you can move the 12 to the front. So 12t log. So the minute you put log on both sides, you can put the 12t in the front. Then you divide by log on both sides, and you get 12t equal to this whole ugly thing, which is fine. You just need to use calculate for that. It's just an ugly decimal. Then when you divide by 12 on both sides, you get approximately 2.4. So t is 2.4. You take about 2.4 more years for him to finish the payments. Okay, so same thing here. If parent deposit $6,000 into an account earning 4% compound monthly, how long will it take account to grow to be $10,000? This is a review, right? But T is missing. All right, so this one is on compound interest formula. So you have $10,000 that you will go. 6,000 times 1 plus interest divided by 12 because compound monthly. Now, once again, just like the previous question, what you need to do is take the log on both sides to move this 12t to the front. Now it's 12t times. So you can now divide log on both sides and divide by 12 in the end. So you get 14.2 years. But what if the interest rate is missing? Go back all the way to the very beginning of the chapter, I equal to PRT. So we have the interest, we have the principal, we don't have the interest rate, but we have the year, right? 19.4 years. Well, then just simple algebra. When you divide, you'll find out the interest rate. In this case, interest rate is 4.9%. So all these things right here, with something that's one of the other two things is missing, it require you to do algebra. Suppose you pay back $385 on a $375 loan. You had the loan for 45 days. What was the simple annual interest? Okay, so we're missing R, right? Okay, so the interest is the $10. How do we know? We pay $385. We only borrow $375. So the interest is what's in between. It's what how bank earn the money, right? It's the $10. So then we have once we have the $10. Okay, we can plug into our formula and PRT. P is 375. Now remember, T is in terms of time. 45 days long, so it's 45 out of 360. Now notice how come it's not 365. Our bank likes to use what we call the banker's rule. They use 360 days in a year instead of 365. So there it is. Okay. Then once you multiply 375 and 45, then times 45 over 360, that's what you get, and you divide by 46.875 on both sides, you get your interest rate.